Intermediate Algebra for Statistics, Finding Quadratic Models. Lesson objective: find an equation of a quadratic model in standard form. Lesson objective: Example 1. The number of house calls paid by Medicare are shown in the table for various years. Let f of t be the number of house calls in the millions paid by Medicare in the year that is t years since 1995. Find an equation of the model to describe the situation. Our first step is to compute the value of t and put that in list 1. So for 1996 this will be 1. 1997 t will be 2. Then we put the number of house calls in y2. Then we want to draw the scattergram or the scatter plot, and then we will use what's called the Graphing Calculator's Quadratic Regression feature. So t goes in list 1, house calls go in list 2. We hit second y equals, make sure the stat plot is on. Hit zoom, number 9, zoom stat, and we have the graph of the data. It looks like a quadratic pattern. Next we hit stat, right arrow to calculate, then number 5, quadratic regression. Hit enter, and we see the values of A, B, and C in standard form. To see how well the model fits the data, we type in the equation in y1 and we hit graph, and we can see that this parabola fits the data very well. So the equation would be f of t equals 0.02 t squared minus 0.15 t plus 1.75. Example 2. The table at the left shows the height of a column of water as it drains from its container. Model the data with a quadratic function. A. Use the model to estimate the water level at 35 seconds. B. Estimate the water level at 25 seconds. C. Use the quadratic model to predict the water level at 3 minutes. Is this prediction reasonable? So our first step is to enter the independent variable elapsed time in list 1, and in list 2 will be the water level. Next, we want to look at the scatter plot of the data. To get the quadratic model, we hit stat, then to calculate, and then number 5, quadratic regression. We hit enter, and we have our values of A, B, and C. Again, to see how well this model fits the data, we need to type in the model in y1. So here's the model with the data points. This model is fitting the pattern very well. So our function is f of x equals 0.009 x squared minus 2.10x plus 120.33. Part B, we want to evaluate this model. So one way we can do that is using the variable key. Hitting the vars key gives us this window. We right arrow to y vars, and then we hit enter for function. We have the model in y1, so we hit enter again. And in the home screen, you type parentheses 35, close parentheses, and hit enter, and you get the corresponding output. So after 35 seconds, there's about 57.9 millimeters. For 25 seconds, we do the same thing, and this time we get about 73.5 millimeters. Part C, we want to know the water level at 3 minutes, which is 180 seconds. And we get an output of 33.93. The question asks, is this reasonable? Looking back at the data, at 60 seconds we had 28. 50 seconds we had 37. So this value here doesn't seem correct. So if we use our table feature, and I'm counting by tens, we see, according to the model, when we get 60 seconds, we have about 27 millimeters. And if we keep going, we can see after 100 seconds, the container is empty because we are getting negative numbers. The water has already been drained after 100 seconds. So we have a model breakdown. Thanks for watching.